Hi Statistics. I wanted to talk to you first about the things that you need to know for your upcoming quiz. You have this list of different things that you need to know, and I'm going to go through each of them just to give you a better sense for what's going to be on this quiz. So first of all, let's think about discrete versus continuous. Here's an example of discrete shoe size. If there's a finite number of options for people's shoe sizes. So that's the type of scale that it's measured on. A continuous example would be weight. There's an infinite number of weights that people could weigh. Say maybe like between 0 and 400 or something like that. Someone could take on any value between those two numbers to weigh. So you also have to be able to graph any probability distribution as a histogram. It's likely that I will give you a table that has x values and frequencies. So let's say it was for the boredom tolerance test. The scores on the test were 0, 1, 2, 3, 4, 5. And I might tell you how many people who took the test in a given group got each score. So I'm just making these numbers up. But let's say this is the number of people who got 0, 1, 2, 3, 4, or 5 on this test. You would first need to turn this into a probability distribution by dividing each frequency by the total number. So the x scores, those stay the same. Those are still the scores people got on the boredom tolerance test. But then you would be filling in the p of x value for each of these. And again, you would do that by taking the frequency, say, of a score of 0, the frequency was 100, and you would have to divide that by the total number of people who took the test. So you would have to add up all the numbers, 100 plus 87 plus 93 plus 57 plus 6 plus 2, to get the total number of people who took the test. To then get the p of x values, the probabilities, you would have to do each frequency divided by that total number. Then, if you wanted to graph it into a histogram, you would set up your axes. Your x values would be on the horizontal, and your p of x values would be vertical. And then you may remember that when we were talking about the difference between a regular probability distribution and a binomial one, it's easy to find whether or not a probability distribution is valid. You add up the probabilities. If they don't add to 1, it's not valid. The hard part about probability distributions is finding the expected value and standard deviation. The expected value is given by the sum of all x times p of x values. And remember, this is the mean, mu. You have that one-page sheet of notes that I gave you that tells you how to find mu and how to find the standard deviation using the lists in your calculator. So you may want to reference that in thinking about what notes you'll need for this quiz. Sigma, the standard deviation, is given by the square root of the sum of x minus mu squared times p of x values. So that one takes a lot to do in the lists of your calculator. And again, you'll want to reference that one-page sheet that I gave you for notes. So now we can move into binomial experiments and binomial probabilities. Remember, for these, the hard part is checking to see if an experiment meets those 5 conditions that we have. So you want to check all 5, and if one of them is not true for a given experiment, then you cannot call it a binomial experiment. So those conditions, the first one, there's a fixed number of trials. The second one, you have to be able to identify success and failure. And you choose what success is. So you can decide success is something negative even. Like say you have the probability of getting a defective pen out of a shipment of pens. You could say success is that the pen is defective, and failure is that the pen is not defective. So it's okay to frame success as something negative. It's your choice what success or failure are. The third condition is that the trials must be independent. And remember, we talked about approximating independence. If you have a very large population and you are sampling without replacement, it's possible to approximate independence for those trials. But if you have a small population and you're sampling without replacement, say you're taking from a group of 30 people or something like that, then you really need to be careful because your trials probably are not going to be even approximately independent. And remember, we check that by doing things like 1 divided by the total population, then 1 divided by 1 less than the total population to see how much those probabilities changed. The fourth condition is that the probability of success must be constant, so it has to be the same for every trial. And then the fifth condition is that you're looking for the probability of R successes out of N trials. So R is the number of successes that you want to see, and N is the total number of trials that you have. You're also going to be responsible for finding the expected value and standard deviation of a binomial distribution. And this is the part that's a little bit easier. These formulas are much nicer than the formulas for regular probability distributions. To find the expected value mu of a probability distribution, you do n times p. N is the number of trials, and p is the probability of success. To find sigma, the standard deviation, you do the square root of n times p times q. And remember, q is the probability of failure. It's equal to 1 minus p. Then the final thing that you need to know is how to identify unusual values. Remember, an unusual value is anything that's outside of the range of 2.5 standard deviations away from the mean. So you can check mu plus 2.5 times sigma and mu minus 2.5 times sigma. If you have a value outside of that range, it's unusual. So in thinking about your studying this week, I recommend that you condense your notes. Try to get them into a single page so you're not having to flip through lots of different papers and things to find what you're looking for on your quiz. Some good things to include would be how to find the expected value and standard deviation of a regular probability distribution with the help of your calculator. You might want to have the conditions for a binomial experiment listed out so you can reference them. Spend time in class this week not only working on the study guide that I gave you, but also putting together your notes so you have them organized.